A proton spin solution is an investigation into perception and energy that yields an explanation of the 1/2 proton spin. This video is a simplification of the book titled The Proton Spin Solution. The theory is an advancement of prior works by Michael Sanborn and Mark Sanborn, referenced at the end of the video. The number counting property of energy fields is an introduction into the space-time properties of numbers. In the 1800s, Ernst Weber observed that the perceived just noticeable difference in electromagnetic and gravitational field perception followed a common mathematical progression. Based on Weber's work, Gustav Fechner formulated a fundamental law of perception, that there is a one-to-one correspondence between physical reality and perception. Given that numbers are the means of defining just noticeable difference, then the communication pathway between perception and physical reality is defined by numbers, which in turn means that numbers are fundamental to perception and physical reality. This fact is verified by Albert Einstein's theory of relativity, which defines that spacetime is relative. In order for spacetime to be relative, there must be an observer and an observed. In order for there to be an observer and an observed, there must exist an information communication, which is governed by the spacetime laws of perception. Fechner's law is not then just for human perception, but encompasses the interaction between all matter and energy, and defines all matter and energy. Fechner's law is then restated as perception is the physical, and the physical is perception, and all communication or information transfer is governed by the spacetime laws of perception. The laws of perception are then defined to be fundamental to the very existence of space and time. The foundation of numbers investigates the origin of numbers in infinity. If nothing exists, and that is the origin, then infinity is the origin. In order for infinity to be an origin, or singular, there can be no other infinity. In order for infinity to be singular, it must be capable of perceiving if there is another infinity. Also, in order for infinity to be singular, it must be capable of maintaining its singularness. The process of maintaining singularity necessarily creates the perception of that which infinity is not. That which infinity is not is necessarily an infinite opposite to infinity. Awareness of oppositeness causes the infinite plane to come into being. The upper side of the infinite plane is defined by that which is. The underside of the infinite plane is defined by that which is not. Because the upper side of the infinite plane perceives that the other side exists, then such perception becomes fundamental to the very existence of the infinite plane. When the new perceptive state is applied to the upper infinite plane, the result is a division of the reference infinity into the two infinities of time and distance. It is important to observe that time and distance are formed from the same substrate, with the only difference between them being that of relative oppositeness. Because the two infinities of time and distance are formed from the same reference infinity, then they are inextricably linked as a relative pair of opposites. The boundary separating them then becomes a point of comparison, where the infinite comparison is a ratio defined by distance compared to time, and where the comparison is defined as infinite velocity. Both time and distance have the fundamental perceptive law of oppositeness, which means they will divide themselves into time and distance states. Time divided by itself is time. Time divided by distance is neutral. Distance divided by itself is distance. Distance divided by time is neutral. The four comparison ratios are distance is counted against a reference 1 time unit, or a counting distance unit is compared against a reference 1 time, and time is counted against a reference 1 distance unit, or a counting time is compared against a reference 1 distance unit. Time and distance are fundamentally opposing infinite states. Is there a pair of numbers that identifies these states? The answer is yes. The perception of numbers is defined by a logarithmic helical space, where opposite sides of the helix define opposite states of perception. The two exactly opposing vectors are defined by the numbers 1 and the square root of 2. If time is defined as 1, then distance will be defined by the square root of 2. On the spacetime helix, time can count by numbers or fractions, and distance can count by numbers or fractions. The time vector defines multiple points along the same side of the helix, which are identified as the powers of 2. The ratio comparison of 1 to 2 is 2, and the difference between them is the reference 1. If 2 becomes the reference, then the ratio of 2 to 4 is also 2, and the difference between them is perceived to be a reference 1. The powers of 2 then define an identity function, which is defined as an identity vector. The inversion vector of time is defined by the fraction series 1 divided by the powers of 2. Distance has a fraction identity vector. The inversion vector of distance is defined by numbers.